Hi, this recording will be on section 2.6, set operations and compound inequalities. And like I said before, it might not be 2.6 in your book, but compound inequalities is basically, and set operations, compound inequalities. So let's look at, we're kind of looking at two things with these compound inequalities. We're going to link them by an and or an or. So the first thing I want to look at is the intersection of two sets. Like, what do they have in common? It's called the intersection of two sets. So these two sets we're going to do is mostly going to be like a math problem, right? But the sets could be like the intersection of two sets could be classroom A, classroom B, or class A, class B. How many people have both class A and B? That would be an intersection of those two sets. And it's defined by the word and. Oops, I can't spell and right today. So it's defined in the way of a Venn diagram as set A, set B, and what's in common. So what is the overlapping section? And the symbols for it is A intersection B. So that's the symbol. It's like an upside down U for an intersection. What is in common? So we have to think about that as we do these math problems. What do they have in common? And some of the problems you'll do will be just basic, like, here's an example. If set A, well, yeah, use set notation here, is 1, 2, 3, 4, 5. And if set B is, oh, I don't know, 4, 5, and 10, then you're going to be asked something like, what's A intersection B? So what's in common between A and B? So you can easily, when you're given a set, probably pick it out. This is going to equal, and then you'll do a set, and you'll put a comma between each one. So what do they have in common? They have 4 and 5. Okay, this one has 10, that one doesn't. That one has 1, 2, 3, that one doesn't. So the set would be 4, 5. The intersection of those two. Do you happen to reach over? I didn't realize it would show my arm. So let's look at an inequality. And inequalities can be defined by and or the word or. And they really can be solved the exact same way, whether it's and or. Just the answer's different if you have an and or an or. So let's look at some and examples. Let's see, oops. So what if we have x plus 3 is less than 1 and x minus 4 is greater than negative 12? So those are my two sets or two problems, and they're connected by an and. What am I really asking when I say and? I could have put the intersection sign there, same word, saying what do they have in common? Where is the solution that works for both? So let's find the solution for each individually. So this one we'll minus the 3 over, and I'm going to have x is less than negative 2. Okay, on this one you have to add the 4 over, and that's going to give me x is greater than negative 8. So let's look at what that looks like on a number line. So if this is 0, 1, 2, that's negative 2, 3, 4, 5, 6, 7, 8. Here's negative 8. This one says x is less than negative 2, and it's a round bracket or an open dot. It kind of depends on your book, but the most of them are going to the parenthesis, partially because you can type a parenthesis easier than you can an open dot. Okay, and then negative 8. X is greater than negative 8. So made myself look like I put a negative there. So this one goes this way. So what do they have in common? This one continues forever, right? This way, and this one continues forever this way. But what they have in common would be where they both are, which is here, just in between those two numbers. So you might pick out a graph of it, or you might put it in interval notation. Interval notation, remember, goes from lowest to highest number with a comma in between, and you use open and closed brackets or parentheses, round or square, basically, right? So we'll use round because there's no equal sign, and we'll go from -8 to -2, including them both. So there's one example. Let's see. You could end up with a problem that sets don't work out. So for example, like you could have no solution. So for example, had I got, no, that still would have worked. Both the other directions for these. Okay, so if I would have solved both of them, and one would have been pointing this way, one would have been pointed this way, and it asks, where are they the same? Where do they overlap? That's not going to work. They don't. So sometimes we use the symbol for no solution. It looks like this. Here's, I'll just put a 3 by this. This means no or empty set. So we like that symbol for an empty set. So do know that sometimes yours doesn't work out, and that's okay. And you might end up with a solution that doesn't work. Okay, so this is kind of our intersection. What's in common? Let's look at a union of two sets. So union of two sets is where you have the word or. Or. So this one or this one's okay. So think about the logic of this. And, right, you have to have both this one and this one. Or, well, you could have this one or this one. So think about the logic of it. That kind of helps. The Venn diagram would be like, okay, if this is set A, this is set B, you would take all of B or all of B. So anything in A or B would work. For example, if I am making this lesson for classes in A or B, which I currently am, then it's a union. Anyone, it's for anyone in A or anyone in B. You don't have to be in one or the other or both. The symbol for this is a U, a union B. Okay, and the problems are super similar. If you have something like, let's look at the set one. Set A is equal to 3, 4, 5, 6. And set B is equal to 5, 6, 7. What is A union B? How would I write that one? A little bit different. Union, take all of A, take all of B, but what's in common, you only want to write it once. So what do we have in common? We have 5 and 6, right, on both. So we only write those down once. So we'll take everything in this set. So we'll take 3, 4, 5, 6. Then over here, we already took the 5 and 6, so then we have to add the 7. Have we included everything in A and everything in B? Then we've now unioned the sets together. Okay, so let's look at the word or in between our inequalities. Oh, you did not hear me yawn like 3 times. At the second I try to make a video, I start yawning. It's ridiculous. So what if I have x minus 1 is greater than 2 or 3x plus 5 is less than 2x plus 6? So here are two inequalities, but this time I say or. So it could be this one or this one. I don't have as many no solutions on these, right? Because the other and more than no solution, because You don't have anything in common. So let's solve these both. We'd add the 1 over, and that's going to be x is greater than 3. Or over here, this one's got a couple steps. Got to get those x's together. First, I like moving them to the left. So you're going to subtract the 2x. Subtract the 2x. That'll give you 3 minus 2 is 1x. And then I'm going to minus the 5 this way. So I kind of did 2 steps in one. Bring down this less than symbol. And the 5, or 6 minus 5 is 1. Okay, so x is greater than 3, or x is less than 1. Let's draw that. I'll draw them. I should have grabbed a different colored pencil so I could do each of them a different color. Oh well. So here's 0, 1, 2, 3. So x is greater than 3. Again, that's a round bracket, and you're going greater than 3. And x is less than 1, round bracket, less than 1. Do they have anything in common? Well, no, they're both going the opposite direction. So for an and, this would be no solution. For an or, you would state both, and you would union them together. So let me state that in interval notation. These are our two answers. We're done. That's our answers. That's them in inequalities. This is them as a graph. But how would we put those as interval notation? We'd say, well, we're going from negative infinity to 1, negative infinity to 1. And we don't include either one exactly there, right? We don't have any equal parts. And then we're going to union that with 3 up to infinity. Ta-da! That's interval notation for that situation. Okay. This one always throws people off. So I'm going to do another or. This camera works really well because it shows like every flaw in my nail polish. Any little thing is going to show it. So here is like my problem 3. So 3x minus 2 is less than or equal to 13, or x plus 5 is less than or equal to 7. So there's our two inequalities. We got our or there. Let's solve these. So we'd add 2, and I get 3x is less than or equal to 15. Divide by 3, and x is less than or equal to 5. Same idea over here, minus the 5, x is going to be less than or equal to 2. And let's look at what the graph will look like for these ones. Okay, so x is less than or equal to 5. Square bracket, because it could equal that, and it's going this way. And at 2, you're less than or equal to 2. So if this was an and, anything less than 2 would solve them both, right? Because you can imagine this arrow keep going, this one keep going, and that's where both arrows would be. For or, you could be this one or this one, so anything less than 5 would work. So we could state that as an interval notation going from negative infinity to 5 and including the 5. So you didn't have to union it together. A lot of times in the or you do on the interval notation, but on that one you did not. Okay, so let me see. Sometimes you could go from infinity to infinity. So for example, had you been from like this number here, like 1 this way, 2 this way, right? It would have been everything. So don't be afraid to have infinity to infinity. That's going to be okay too. Yeah, and I think that's about all I wanted to show for this section. So I'll end this video.